Okay, alright, so in this video I will continue with we have three methods, right? So we have three methods, so I do it first. Gauss elimination. Okay, so I show you how to solve Gauss elimination first. Because of why? Because of it's more what we call related to the what we do before, row echelon form. Okay, right. So basically, so the basic idea lah in beside what we call the basic idea of the algorithm of the Gauss elimination itself. So you will given a linear system. Okay, you will given a linear system. For example, x1 plus 2x2 plus 3x3 equal to 4. And then 2x1 plus x2 plus 4x3 equal to 5. x1 plus 4x2 plus 9x3 equal to 6. For example, okay. So this is what we call as a linear system. Okay, this is a linear system. Okay, so this is a linear system. So next, what we need to do next is we will change it become matrix form. Okay, if you still remember the introduction, so this is the matrix form. So you have a matrix A. So matrix A is a coefficient. Matrix X is variables, and matrix B is a solution. Okay, let's say kita transform this one into matrix form. So here should be 1, 2, 3, 2, 1, 4, 1, 4, 9. Okay, so this is matrix A. Matrix X is a variable. Variable involved here is x1, x2, and x3. And B is the solution or the answer. So 4, 5, 6. So this is what we call as a matrix form. Right? Okay, so then the next step in the Gauss elimination. Okay, so this is basically is a basic idea about the solution. At the same time, is the step lah. Okay, the step. Okay, so after you have a matrix form, you need to change it become what we call it as augmented matrix. What is augmented matrix? Augmented matrix is a matrices, but it is in what we call A, B. Okay, A, B maksudnya tak ada X. Kat sini augmented matrix ni, X tu bukanlah hilang, tapi in augmented matrix we know that X is behind that. Maksudnya X tu ada tapi kita tak tulis. So augmented matrix mean this matrix A and B. So 1, 2, 3, 2, 1, 4, 1, 4, 9, and matrix B here is 4, 5, 6. Okay, so this is the augmented matrix. Okay, after that what we do next? Okay, what we do next? Okay, from the augmented matrix, okay, saya tulis kat sini boleh? Boleh Okay, I just want to finish up in one page. Okay, after augmented matrix, okay, this is the flow. Okay, now we turn left. Okay, so or turn right lah. It sides. Okay, so now from this, what we do? We do the row reduction. Row reduction. So means that you will reduce it. This matrix become row echelon form. Row echelon form baru tadi kita buat. Baru tadi video yang saya tunjukkan tadi. Okay, row reduction. So in row reduction you will use ARO, and then the objective is to make it become row echelon form or what? Or upper triangular. So after you get a row echelon form, okay, so kalau tadi means that after you get the row echelon form, then you can stop. So that is for row echelon form. You reduce the matrix, but now this is Gauss elimination. So they have another extra steps, which is a back substitution. Okay, so for the backward substitution here is to find out what is your x1, what is your x2, and what is your x3. Okay, please remember, because of this is solution of linear system. Solution. So means that at the final step, the final answer should have an answer. I mean the value of x. X it's depend on variable apa dia guna. Kalau x, y, z, so x, y, z lah. But now for this example, it use x1, x2, x3. So therefore, at the end, you will apply the back substitution to get the value of x1, x2, and x3. So this is the basic idea, or this is the steps in the Gauss elimination, okay, the algorithm, okay. So you have a question here, nanti you akan dapat soalan linear system. You can just what we call can ignore this one. I mean you boleh abaikan ni, you terus tulis this one, you terus jump to augmented matrix. Kalau you dah familiar dengan ni, you boleh terus augmented matrix. So from augmented matrix, you will do the row reduction, okay, and then after that back substitution to get the answer, okay. Right, so that one is the basic idea. So now I will show the steps, okay, the steps one by one, okay. I'm using the example in the slides, so you can refer the question from the slide lah. Okay, this is the example. So the example asks you to solve the following linear system, okay, solve matrices tu by using blah blah blah, okay, by using Gauss elimination. Gauss elimination. So please don't get confused. They have two Gauss, Gauss-sided and Gauss elimination. So what I do now is Gauss elimination. Okay. So this is the systems, the linear system that you have. So the question asks you to solve this linear system by using Gauss elimination. Okay, so now we go to the solution. Okay, so the first step is what? The first step, you can write the matrix form first. Kalau ataupun for me, if you are already familiar ataupun you dah biasa, you terus jump to augmented matrix. So I suggest you terus jump to augmented matrix lah. So step number 1, you write your augmented matrix. So augmented matrix is just contain A and B, right? So A and B. So this is a matrix A. And they have a something like palang kat tengah ni, and this is your matrix B. Okay, so this is the augmented matrix. Okay, augmented matrix. So now we will reduce it. Okay, we will reduce this matrix, augmented matrix, into row echelon form. Kita nak jadikan 3 bawah ni kosong. So we apply the row ERO. Okay, kita akan apply ERO. So basically dia similar lah macam yang kita buat tadi, cuma dia ada extra matrix B. So tak ada, tapi tak ada masalah apa-apa. Means that you still can do it by you still can do it as usual, tak ada masalah. Okay, so cuma ada extra lah, dia ada extra kat sini. Okay, so row 1 they have is no changes, so you can write your row 1. Row 3 also they have no changes yet, so you can write your 3. So the changes now is on row 2. So row 2 so row 2, okay, 4 is lies on row 2 plus M1, okay, M1 times with R1. Okay, so your R2 here is 4 plus M1, R1 here is 2, and our objective, okay, because of we know we want to make it 4 become 0. So you can write 0 actually kat sini, tak boleh tulis kosong, tak ada masalah. Cuma for the rest you cannot write anything yet, because it's depend on your M1 here. So now we want to find the M1. So 4 plus 2 M1 equal to 0. Therefore, what is your M1 here? Negative 2, betul? So your M1 is negative 2. Okay, so your row replacement operation here kat sini dia akan jadi R2. Okay, substitute back your M1 here, minus 2R1. Okay, row 2 minus 2R1. Okay, so now Okay, this is already 0. So now the rest kat sini semua ni 491 491. So you should get the new value. So we do it for the 4 first. So 4 plus or 4 minus 2, your R1 here is 3. So you should get 4 minus 6, you should get negative 2. So here is negative 2. So negative 1, do it the same thing, negative 1 minus 2 times with negative 1. So you should get negative 1 plus 2, you get 1. So you write here 1. And then for this one, kat sini pun samalah kena buat juga. Okay, so this is the extra thing that you need calculate lah, tak ada apa pun kan. So negative 1 here minus 2 times with 2. So negative 1 minus 4 negative 5. So here is negative 5. Okay, so then you can do it another one for this is the first stage, and then you proceed to the second stage. So second stage, now you want to make it, or you want to change this figure, this number becomes 0. So that's mean row 1 and row 2 there is no changes. Okay, you can take the latest one lah. Okay, like I said, you take the latest one. The original one you can abaikan lah. Okay, alright, so now okay, negative 2, we know that we want to make it 0, so you can write directly 0 here. So what we do next is we want to find out your M2. So negative 2 is located at row 3, right? Plus M2, and is times with R2 or R1? Yeah, R1. Okay, still remember atas dia kosong, so tak boleh pilih R2, dia kena pilih yang ada value lah. So you will choose R1. So your R3 here is negative 2. Your M2 still we don't know yet. Your R1 here is 2, and this equation should be equal to 0. Okay, so now negative 2 plus 2M2. So therefore, what is your M2? Your M2 is 1. So the equation here is R3. Okay, M2 substitute back here plus R1. Okay, R2 plus R1. So therefore, by using these operations, row replacement operation, you can find out another 3 value here. So you can do it the same thing like you do it this. So negative 3 first. Okay, okay, I write here negative 3 plus R1, and you should get 0. Okay, 4 plus negative R1, so maksudnya plus minus 1 lah. You get what we call, what we get 3. Okay, and then the last one is 1 plus R1. You get 3. Okay, so now you get all the matrices. I mean, you get the new matrices here. The latest one is this. So now check. You already fill, or you already what we call get all zeros or not for the what we call for this one. Yes, you already get 0 here also. Kebetulan sangat kan, bila you buat the second one, you get 0. Kalau you tak dapat kosong lagi, maksudnya you kena buat another one lah. Tapi kat sini dia dapat kosong dah, so rezeki you. Okay, rezeki sangat, tak payah buat lagi panjang-panjang. Okay, so means that you can stop now. Okay, because you already reduce it become row echelon form. So you can stop until this matrix. Okay, but please remember, this is Gauss elimination, right? So they have another one last steps. Okay, what is the one last step? The one last step here is a back substitution. Back substitution. Okay, backward substitution. Okay, what mean by backward substitution? Okay, you can see that this is the latest matrix, right? So I write here lah. Okay, supaya nak dapat 2, 3, negative 1, 0, negative 2, 1, negative 5, 0, 0, 3, 3. Okay, so this is the last one, the last matrix that you have. So what's mean by back substitution is you will start from the last row. Okay, they have two. Actually, they have two in mathematics. They have forward substitution and also backward. Forward, backward. So what's mean by forward? We start first with the row 1, the first one. Okay, the early one. of and then meanwhile for backward means that the last row, anything we start from the back lah, maksudnya senang kata yang backward kita start yang belakang dulu, yang forward kita akan start depan dulu. So this is a backward solution. So okay, kat sini lah, fokusnya kat sini. Alright, so backward solution here. Okay, so this is augmented matrix, right? This is A, this is B, and like I said before, actually dekat belakang tu ada variable x1, x2 and x3. So we know that x1 is, this is the coefficient for x1, right? Okay, macam ni kalau you tengok 2, 4, -2. Okay, tadilah at the first tadi 2, 4, -2. Okay, it's a coefficient for x1. 3, 4, -3. 3, 4, -3 is a coefficient for x2. -1, -1, 4. -1, -1, 4 is a coefficient for x3. So means that row 1 is a x1, row 2 is x2, row 3 as x3. Sorry, it's not row, it's column. Column 1 is 1, column 2 is x2, column 3 is x3. So same thing, means that here is a coefficient for x1, here is a coefficient for x2, and here is coefficient for x3. So what's mean by backward is we start first with the last row. So the last row we just left with 3, and this 3 is 3x cube. Okay, remember this column is x3, this column is x2, this column is x1. So when we start with the row 3, row yang terakhir ni, we just qualify and 3, kita ada cuma ada 3 kat sini, and this 3 is a 3x3. 3x3. Okay, and this equation, okay, is equal to 3. Okay, 3x3 equal to 3. Okay, macamnya equal to B lah, equal to B. Okay, so therefore now you can find what is your x3. Your x3 is equal to 1. So you already get the value for x3. So the next one, the next step is to find the value for x2. So to find the value x2, so you choose or you use the row number 2. Maksudnya macam ni lah, backward ni maksudnya kita start dengan row terakhir, lepas tu kita makin naik lah, row 3, row 2, row 1. So now we go to row number 2. So row number 2, they have -2, and this -2, the variable here is x2, and then plus 1, the variable here is x3. Okay, and this equation is equal to -5. Okay, so and x3 you already get the value here, so substitute your x3 here, so you have -2, sorry, -x2 plus 1 equal to -5. -2x2 equal to -1, bring here, so -6. x2 is equal to 3. Is it? Okay, so your x2 is equal to 3. So you already get the value for x2. So now the last one is to find x1. So you will use this first row. Okay, the variable, the variable here is x1 plus, what is that here tadi? 3. 3x2 minus 1x3, and this equation is equal to 2. So this value and this you already get it from here. So x2 you substitute here, x3 you substitute here. So 2x1 plus 3, x2 here is 3 minus 1 equal to 2. So simplify lah. Okay. So 2x2 plus 8 equal to 2. 2x1 equal to -6, x1 equal to -3. So you already get all the values of the variable. Therefore, your final answer is -3 for x1, 3 for x2, and 1 for x3. So this is your final answer. Okay, So this is how the algorithm or the steps for the Gauss elimination. Alright, so you can try by yourself this example. So they have another one example in the slides. Okay, kalau you tengok example yang kedua ni, untuk row number 3, you can refer. Saya just cakap sekarang, nanti you can refer to the slides. If you can see example, the second example in the Gauss elimination, for the row number 3, they have only 3x1 and then x3 minus x3. They have no, I mean there's no what we call x2, kat situ tak ada x2. So when, okay, bila maksudnya tak ada ataupun doesn't stated any x1 ke x2 ke x3, maksudnya variable tu tak ada. So maksudnya at the particular equation tu maksudnya kosong lah x2 dia. Kalau x2 yang tak ada, maksudnya x2 dia kosong. Okay, so you can refer to the slide later on, and then they have also exercise, so you can try by yourself lah, do it the exercise. Okay, so in the next video I will explain on the LU decomposition method.